Yeah, I'm Feross, and I'm the CEO and founder of Socket. So Socket is a developer first security tool for helping you use open source software safely. I've been an open source maintainer for most of the past 10 years, and I've written a lot of open source packages in the JavaScript ecosystem. And I'm also a lecturer in web security at Stanford for the CS 253 class there, which is also really fun.
Um, so I know right before we recorded, I told you what I was going to ask you, and I'm going to change what I'm going to ask you. Because something you told me another time when we spoke was as a maintainer, you finding you finding how far and wide your your work was.
Mhm.
Um, so how far and wide is your work? How did you find that out?
Yeah, so I mean, I think a lot of people don't realize the reach of some of these open source dependencies. And I realized this for myself when I was, I was getting started in open source in my kind of early to mid 20s. Started writing some JavaScript libraries, publishing them to npm, and then finding that the early ones were pretty bad, but eventually I started writing some useful stuff, I think, and people started using it. And Yeah, and then what really shocked me was the download counts on some of these packages, right? Like the scale of the JavaScript ecosystem was mind-boggling. Like I think right now my packages get something like I think it's like 500 million plus monthly downloads. I don't know what it was at the time when I was starting, but like I quickly realized that that code was ending up in lots and lots and lots of applications, and applications written by the Fortune 500, right? I'd even find that code in the source code on people's websites, and that's about as explicit proof that you need that the code is getting into the company as you can get. So yeah, it was definitely pretty eye-opening for me, and it made me just realize that, well, if this is the case for every open source maintainer, if everybody has this level of reach into these companies, it's just a lot of responsibility, and it's important to be careful.
Well, so it is for the maintainer, but like flip it the other way. Like how many dependencies are there? I think that um, there's a assumption on people's uh, some people's account that they don't realize that they have. Some people on the business side may not realize they have any open source. So roughly how much open source is running in a company?
Well, I mean, so it's hard to get like official stats on this because all the code is most companies' code is private, but the estimates that you'll see often are something like 80 to 90% of all the lines of code in the average application are actually lines of open source code. Now, obviously, it's a little bit arbitrary. Where do you draw the line? Like, does the operating system, does Linux count as part of the application? And so, but I mean, I think if you just say, like, let's take the app itself, and you take like an average modern web application, or like, let's say a Node or Python application, I would not I would say I think most people would find it pretty reasonable that to estimate that like 80-90% of the lines of code are coming from those third-party dependencies.
Well, that also leads to the question that you and I initially were connected on, which is the number of dependencies and the concept of known vulnerabilities. And I think that you have a strong opinion on scanning for known vulnerabilities. And what is your take on that?
Yeah, I mean, so the like first the kind of most natural thing that companies want to do once they realize like how much code they're bringing in from third parties is they want to do something about it and like make it more secure. And I think what the market and like what the security vendors have ended up focusing on is scanning for these known vulnerabilities, also known as CVEs, that are present in open source dependencies. And most of these scanners merely look up the packages that you're using and compare them to the public CVE databases, and tell you if you're using anything that's known to have a vulnerability. The problem is, though, that this is and I guess before I jump into the problem, I'll just say it makes sense to do that. It's a reasonable thing to do. That said, it's too slow and too reactive to stop a whole class of other types of risks when it comes to using open source. The most relevant example are supply chain attacks. If a package is compromised or hijacked, or has unwanted code added, or the package is sold to a different maintainer, or a whole host of other reasons, you're gonna be disappointed that there's no CVE for those types of things, right? Another example is if you install the wrong package, right? You make a typo, and a developer installs something that's one letter off from the intended package. In ecosystems like NPM, that will give that package immediate remote code exec on their machine. So that package can, like, literally that typo, you make a typo, you hit enter, boom, like your entire computer could be compromised by that one typo command. And again, like, that package probably doesn't have any CVEs, because it probably doesn't have that many downloads if it's a typo, and they're just hoping that people are going to make the mistake of installing it. And so I could go on, the list is really long of these types of different attacks that fall outside of the concept of a vulnerability. But yeah, that's kind of what we're really focused on at Socket, is like expanding the scope of, like, what does it mean to be secure in the dependencies that you're using beyond just vulnerabilities, but kind of looking at a holistic picture.
Well, and I think that, I mean, you come from the open source community. I have a very strong, I'm a very strong supporter of the open source community. I would say that I still believe that open source is more secure than proprietary, or at least as secure. And I'm still going to say more secure.
I totally agree with you. I love open source, and none of this is to imply that you should switch to using something proprietary, for sure. Yeah,
Yeah.
no, I totally agree. At least with open source, right? The code is there, and you can find these things. You can find, there's source code that you can look at where you can identify both vulnerabilities and these types of attacks. If you're just getting like a proprietary application given to you and it's just a binary, like, it's way harder to find these things. So definitely not trying to say people should suddenly start porting, switching off of open source. Like, definitely open source has won, and it's going to be here to stay, and no one's going to stop using it.
Yeah, but but now we get to the thing of, not to go onto the regulatory part about who is in fact, I purposely for this one to stay away from the regulatory, depending on what geo you are in, whose responsibility it is to about the security, to make sure that it is secure. But I do think that there is, when you're looking at coming back to vulnerabilities and the difference between the known vulnerabilities, it's not just that it's known, it also is, because there are so many, there's a alert fatigue overall is something you hear about in security. People don't necessarily think about it at the developer level. And I think that is a real thing as well. As far as the, if you're getting alerts that there are, potential vulnerabilities, how many are you getting, and how likely are you to just zone out on them?
Mm-hmm. Well, that's the number one complaint that developers have about security tools, is that they're alert fatigue, right? Alert fatigue. Everyone gets too many alerts, and at some point the human brain just shuts off and says, okay, this source of noise is not useful to me. So they start ignoring it unless they're forced. and then when they're, as a security practitioner, forcing people to do things is never the preferred solution, especially when it comes to the relationship between developers and the security team. Developers don't like their productivity being affected by tools that they can't see the value of. So yeah, I think basically the number one problem with most of the existing vulnerability tooling is just the noise level. and that's for a few. I mean, there's a whole bunch of reasons really why it's gotten so bad, but I'll just mention a few. Like one is obviously the incentive of the companies that sell this type of data. They want the database of vulnerabilities to be as big as possible, and they'll often pay for security researchers to look for more and more vulnerabilities, and at some point you start to get down to the bottom of the barrel in terms of the significance of some of these vulnerabilities that they're identifying. So there's that incentive.
What do you mean by that?
Well, just I mean, if you all these vendors are really reselling the national vulnerability database and sort of augmenting it with some of their own proprietary data.
Mm-hmm.
But like anyone who finds a really significant vulnerability is going to get a CVE number issued for it, and it's going to go out to all the vendors. And so
Mm-hmm.
what's left that's not in that database is like the more marginal, insignificant type of findings that these vendors will add just to their own database and not necessarily share it with everybody. And so the numbers will get bigger. They'll just say that they have the biggest database, but we're talking about like stuff that isn't necessarily like a risk in your application. It's not necessarily worth anyone's time to go and spend a bunch of time trying to like fix these when they're not even reachable, or they're not even exploitable in any way. So
it's almost like the quality of the vulnerability, if that makes sense.
Yeah, I think so. Yeah.
Or relevance, maybe
The
relevance.
relevance, yeah. And just even the severities of a lot of these are rated really high. Like, the common one that developers really don't like is that always comes up in discussions around this is regular expression denial of service, which is when you have like a regular expression that is theoretically it's possible for an attacker to send an input in that would cause that regular expression to take a really long time. And so in theory, you can use this to like make a really expensive request to a server and cause it to slow down, and then denial of service it. But that that is, in my opinion, so low on the list of priorities for a developer. And a lot of times too, a lot of this tooling is like developer tooling, meaning it's never even deployed to production. It's in a dependency that they're just using locally for part of their build process. And so they can, the developer controls the input. They're not going to deny of service themselves. And so when that gets marked as a critical or as a high, it really destroys trust in the whole system for a lot of these developers. And they're just like, well, why am I bothering with this thing? This is like not a real good use of my time. And so, yeah, so that's a big part of it. I could go on, there's many other reasons, but yeah, there's just a few.
Well, it's one of those things where I think that the other part, there's there's also the timing of it, because I would say that the vulnerabilities, if it's a known vulnerability, it's by definition a reactive piece of it. It's not what is, you're not catching the newest thing. To your point, it's a catalog.
Yeah. I mean, perfect example of that, right, is there's so many instances of this, but I'll just mention one instance. So there's this new sort of relatively new trend of open source maintainers creating what has been called protestware, which is basically developers using their open source projects to voice their opinions, and they'll add in broken code or protest messages or some type of damaging functionality into their projects without warning. And this causes issues whenever that dependency gets pulled into a project, because then that code just starts getting run by surprise, and it's usually not documented. So like one recent example of this was when the developer of the package event source polyfill added code that would show web visitors some anti-war messages, and then it would redirect them to a petition website to protest Russia's invasion of Ukraine. Now, while open source software is like usually pretty reliable, when you do this type of, like, I would say, self-sabotage to your own projects, it does raise concerns about the overall reliability of the ecosystem, and it's certainly not something that the consumer of that software expects to be added. And so that's like, that's just like one example. There's been other even worse examples of folks adding infinite loops, or adding like password stealers or cryptocurrency miners, or selling their packages to someone else to do who knows what with. So, it's not really easy for a developer who's using software to really investigate all the security aspects of the package and whether or not it's going to do these, these types of behaviors, especially with the amount of open source that they're using. If you have 1,000 dependencies, the amount of time and effort required for you to kind of go in and investigate each one for any instances of hidden or unwanted or undocumented behavior is just like out of the question for most people. So, so yeah, that's why we think that Socket is a really great way to sort of do this at scale, like in an automatic way.
Well, so if what about the idea of it appearing to being the maintainer and not being the maintainer? Have you seen that as well, where somebody will source code will be added in the name of a maintainer, and it ends up not necessarily being who you expect it to be from an account perspective?
Yeah, I mean, one unfortunate thing about the way that GitHub works is that you can upload any like Git repository that you want, and put in Git will let you put in whatever email address you want for the commits in that repository. And then GitHub will helpfully, when it sees that repository, it will helpfully go and match those emails to the user accounts that they know are using, that have those emails registered, and they'll put in the avatar and they'll put in the username and they'll say that such and such person committed this code. And there's no validation before they do that. So it's really easy to put up a repo and have unsuspecting people come by and think that it was written by somebody else. Now you can sign your commits and then they'll put a little check mark next to it or something, but almost nobody uses that. So so yeah, it's definitely easy to trick folks into thinking that code is written by somebody who didn't write it. It's even worse too when it comes to like NPM and PyPy, and a lot of these registries will actually not even validate that the code on GitHub matches the code published to the registry. So that means is if you go to GitHub thinking that, oh, I'll just check out this package and I'll look at the code on GitHub, the code on GitHub might be fine. It actually might be, there might be nothing wrong with it, but the code that's actually in the package that's hosted by PyPy or NPM is going to contain completely different code. They could hide the bad behavior in that. And so it's just to even get to the source of truth, like what is the source code that I'm actually going to run, is a little bit challenging today.
Do you see there being a answer on that side, or is that like the whole reason why, or one of the reasons why Socket would be necessary?
Yeah, I mean, they can do better for sure. I mean, I think just putting the code of the packages on the website, like so you can click and see it. When Socket came out, that was one of the first features we released. So you can go look up a package on Socket and you can see there's a tab that's called File Explorer, and if you click it, you just see the contents of the package right there. So since we launched, NPM has also added that feature as well, and I don't know if PyPy has yet, but so that's a start. But I mean, you're still dealing with developers that are overwhelmed and busy, and they're not going to, in general, they're not going to have time to look at every line of code of every dependency that they're using. And so there is a need for like automation and doing something that scales, and so that's where we get into like what Socket does. But you can kind of think of it as like, if I think of it as there's like two extremes there. If you think of like a on the one side, right, you have like, we could audit every line of code in our dependencies. We could just treat it as our code, like literally treat it, do a code review of every line of code. And then on the opposite extreme, you can do nothing. You can just sort of install whatever and just maybe you look at the number of GitHub stars, or you look at the number of downloads, and then you assume whatever, it's fine, I'm just going to use it, and trust the community to have vetted it, right? So those are the two extremes. I think the first extreme is too expensive. So to audit every line of code is something that like only the largest companies can do. I think Google does something like that, for example, but they often, even with their resources, they're actually often behind on the keeping up to date with the latest versions of their libraries that they're using. So if you're trying to build a culture where the developer can move fast and can use the latest version of their open source packages, then that approach it's just too expensive and it's too slow. And then the other extreme where you do nothing, it means that you're completely susceptible to these supply chain attacks, and you're going to be scrambling when you read a headline, next month that says, "Hey, this package was compromised." You're going to be like, "Oh, well, I don't know. Did we run it at our company? I guess we should check and see." And then you're sort of hoping that you got lucky and you didn't happen to install it while that malware was live. So I think that the solution has to be somewhere in the middle of those extremes. Like Socket is basically a way to use automation and scan all these packages looking for risks, and to do it for all your dependencies in a way that doesn't really add any workload to the developer. And it's not going to be as good, obviously, as a human review, but it's quite good. Like it'll find a lot of stuff, and only stuff that's like, our bar is, it has to be like worth the developer's time, because we are developers and we don't want to show them stuff that isn't going to be worth their time. So we're looking for stuff like malware, typo squats, malicious install scripts, telemetry. So, some packages steal information, like steal, data off the system, or even just collect it for analytics purposes. That type of stuff.
Well, I know that one of the things that you had told me was that, as far as the review, people are more likely to do reviews of their peers within their organization than what's coming from outside, which sounds crazy.
Yeah, it is crazy. I mean, when you see a code, when you see a pull request come from one of your teammates, all the code that they wrote is right there in the GitHub interface. It's showing you exactly what new code they added, what code they deleted, and you can review it quite easily. But if they happen to add a dependency, usually all what you see is a one-line change saying that they added that dependency, and it doesn't show you any of the code in the dependency, or it also doesn't show you the number of additional dependencies that dependency might rely on. So you see these like simple one-line changes that are easy to gloss over, but that's masking the fact that there might be 10 times the amount of code as is in the rest of the pull request that's coming in through that one-line dependency that no one's looking at. And it's it's a little odd if you think about it, because that is code written by somebody who's not even on your team. Like they're not even at your company. They're just a random person. And in my case, it could be like a random, 20-something-year-old who, who just like wrote this code for fun. It could be their first open source project that they've ever written. So there's something feels odd about the fact that we're scrutinizing our teammates and our colleagues' code so closely, and we're just completely giving a free pass to the open source code. And again, like, not to say that open source is bad or anything like that. Obviously, it's most maintainers are good, but when you have an open ecosystem where anyone can publish anything to these registries and anyone can update them at any time, that's when you need to be a little bit more careful than just saying, well, it's open source, so it must be fine, right? Like that's not a responsible way to be.
Well, and I think that's the point that we both get out from two different directions, but we both get at is that, it's not that, in your case, it's not that you shouldn't have alerts at all. It's just make them relevant so that when a developer actually sees an alert, they care about it and they realize it is a reason why that they should be looking at it, as opposed, and make sure that you are not letting things slip through because of, as you said, like one line dependency that mushrooms into a beautiful bloom of a flower of death coming through your one line of code.
The average dependency has 79 additional dependencies in JavaScript.
I did not know that, but that actually does not surprise me. And you could have told me 3 times that, and I would have believed that too, because I would have just kept going. And then they had.
At some point, fortunately, it does end. There's not like an infinite cycle.
I will say that one of the things that drives me crazy is in the security community when I hear developers don't like security. And that's not true at all.
Mhm.
They don't like things that slow them down. They don't like things that don't make sense. But or that, you'll have within an organization, the developers don't like security, the security team, because it's stopping them from deploying. This would be the reason why you need to be looking at the security up front so that you don't have those slowdowns at the end. It's not that developers hate security. I find that a somewhat offensive statement, because that there is somebody sitting somewhere who's like, I don't care about any of this. I think that's a small margin, just like you said, like most of the community, when you're looking at that larger community, when you say by and large, it is a massive amount of people who are doing things for the good of the community. That's the whole point of a community.
Yeah, totally agree. And I think that when it's done tastefully, everyone likes to say shift left. It's easier to fix issues when it's when you catch them sooner. But I think that like most of the companies saying that it's really a marketing term. It's not really, I mean,
Yes.
the stuff that they're doing is just, it seems like it's being rejected by developers, at least, for most vendors, it's not really working. So I think
I would argue you need security throughout the process,
mhm,
and it needs
yeah.
to be, like everything, low friction.
Mm-hmm. It needs to make their job better. Like it needs to help them do their job better. So I think, the way we've thought about it at Socket is we're actually going beyond just security in a lot of ways. So like one of the things, so our most popular product is Socket for GitHub, which is the thing I mentioned that's proactively scans GitHub pull requests for dependency risks. And gives them feedback on any risks that are present. One of the things we added recently is a dependency overview comment that we will leave. And we do that even when there's no risks found. And what that comment does is it summarizes like what are the dependencies that are being brought in that pull request. And it highlights a bunch of like key facts about them. So for example, we have sort of like a nutrition facts label type thing. So it's similar to what you'd find on food. It says, this package uses the network, it uses the file system, it uses your environment variables, it uses, it creates child processes. And we'll just put that in there into a comment, along with other info like the size of the dependency, the number of transitive dependencies, the person who published it. And it's not necessarily actionable, but it's also not blocking the developer. We think of it as sort of like ambient useful information to just provide. And it's the kind of information that would take the developer, hours or days in the case of some really big dependencies to figure out like what are the capabilities of this package. If you were to have to audit every line of code, and we're just going to put that there for them. And so that way, they can see, oh, wait a minute, like, why is this package that I thought was really simple? It's like, I was going to write a 100-line function, but then I decided I would just use the dependency instead. Why is it bringing in, 50,000 lines of code? I could write it at 100 lines. And so you just putting that info there, it'll give the developer team at least a chance to do the right thing and to question like, well, why does it need that permission? Like, why does this need the network? Like, this is just parsing a string. Like, why is it making network calls? Like what, and then you can click on that and see what exactly is it doing. And so that's a perfect example of, we're not slowing the developer down. We're not blocking them. We're just giving them info that it would have taken them hours to find. And so, it's almost not even a security tool in some ways. It's just a useful developer tool. So, I don't know if that makes sense, but that's kind of how we are thinking about it.
I think that makes a ton of sense. I think it is it could end up being used for development or auditing or regulatory. I mean, there's a ton of ways it could be used. To your point, it's not slowing them down, it's giving them information, and and in a way that, and this goes back to, in a frictionless way that is which is a whole other can of worms of why, for every requirement to do something, when you put it in front of anyone, but particularly when you put it in front of a builder, an innovative person, there's a workaround.
Mhm.
You know, and that's definitely not, yeah, you don't want your team innovating on how to get around the thing that you've put for them to do.
Mhm.
So I appreciate it, and I'm glad that you mentioned that, because that is important, and it's part of the, I would say, your commitment to serving the community beyond just the, like, we're here to do this
Mhm.
one thing. So I'm glad that we got a chance to talk. I'm sure we'll talk again in the future, but I really appreciate it. Thanks so much.
Yeah, thank you, Chris.
Take
Thank you
care.
for having me.
Cheers. Bye.
Yeah.